All right, in unit 10, or excuse me, in unit 11, we covered a lot of ideas about like counting, probability, exclusive events, Pascal's triangle, permutations, combinations. So we kind of dealt with the branch of mathematics and like with statistics and probability, counting principles. So to kind of recap, we had permutations where we had to use this idea of factorials, where again, 10 factorial means 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. And then we came up with this idea of a permutation, which describes things in a very specific order. So in a permutation, the order that events are chosen, the order that they're in matters. Whereas combinations do not necessarily mean that the order matters. So if I had the letters ABA and the letters AAB, as far as a combination is concerned, there are two A's and one B. That's going to be the same thing. So order is not as important in combinations. We talked about different types of probabilities and how to kind of go about calculating them. One of the big differences that we talked about with probabilities here was and versus or. And meaning that you have to have both events, or meaning it's one or the other. So you don't necessarily need both of them to happen. And then we kind of finished up the unit with binomial distributions, where again, we had to use combinations. So then we had this idea of the complement, which is like if we put the word not into it. So if I wanted the opposite of something, so I wanted to say, what's the probability of not rolling a positive number? Well, I would take 100, start with my whole thing 100% and subtract what the probability was to get an even number, and whatever is left over is going to give me my answer. So again, we started with the counting principle and permutations to find total number of ways. Again, permutations, order matters. Here's some problems you can try on your own. Then we moved on to combinations and the binomial theorem. Again, the binomial theorem uses Pascal's triangle. So it can be very useful, and it's like a shortcut. So make sure you're familiar with Pascal's triangle. Then we got into kind of like our probability ideas. Again, rolling number cubes, drawing cards, flipping coins. Those are classic probability problems that you may see on your test. Then we talked about disjoint and overlapping events. We used sort of like a Venn diagram. We use circles to show if the circles are overlapping or if the circles are separate, and to determine, this is when we first introduced the and the or idea. Then we've moved into independent and dependent events. So again, if one needs to happen before the other can happen, then it's going to be dependent. If they are standalone events where one does not affect the other, they're going to be independent. We oftentimes use the word replace with independent because I'm putting it back, so nothing is changing. If you are without replacement, or if you do not replace, that's often dependent, because again, if I had 10 cards or 10 marbles in a bag, I pull one out and I don't put it back in, I do not replace it, I'm going to still have not 10, this time I'm going to have 9 marbles in the bag. So it's dependent on that first draw. And then, like we kind of just talked about at the beginning, constructing and interpreting binomial distributions. Again, it's a kind of Once you figure out what your data is, it becomes a little bit of like plug and chug, just using our calculator. Remember the helpful hint we had for finding combinations and permutations. Okay. Yes, we have a formula to use it, and you can absolutely do that. Or if you notice right here, we have permutation, and then we also have combination. So what would it be? 5, 3, and you could get an answer of 10.